So hi guys, welcome to Insane Techie. So in this video we would be discussing about how to solve the Fibonacci series using dynamic programming. So in the previous video we have already covered how we have solved Fibonacci series with the help of recursion. So it's a continuity to that video. So if you already know how we have created this recursive tree, then you can watch this video directly. Otherwise I would recommend to go back to that video. So what is dynamic programming? So dynamic programming is nothing but an optimization over recursion. So in the case of recursion, there are many overlapping conditions. So the first function call is Fibonacci of 5, right? Then it will do some computation. Then it would break into Fibonacci of 4. Then Fibonacci of 4 will call Fibonacci of 3. Then it will do some computation. Same Fibonacci of 2, 1, 0. So they all will do some computation, right? So as you can see here, this Fibonacci of 3, this is getting overlapped with this particular Fibonacci of 3. So this is computed twice. Similarly, Fibonacci of 2, this is also computed twice. Fibonacci of 1, this is computed 1, 2, 3. So you can see Fibonacci of 2 is computed here also. So there are so many overlapping conditions, right? So to fix this problem, there is a way which is well known by the name dynamic programming. So I have already written a solution for it to save the time. First step is like we have to create an array of size n plus 1. N would be 5 in our case. So we will create an array for this and we will initialize it with invalid. What we will do with this array, we will store the output of each function call in this particular array. Okay. So in this recursive call, firstly it will go to Fibo 5, then Fibo 4, 3, 2, 1. Then the value of 1 would be stored in this array. Then after that 0 would be stored here, 2 would be stored here. Then for the 1, we already have the value of 1 in our array, right, which was computed here. So it will directly return it. So the same thing will go on for all. So even for this heaviest part, Fibo of 3, here also when we will come to this part, it will see, okay, we already have some value for Fibo 3. We will just use this value. So in the pseudocode also, what I have done is I have just modified our recursive code. Okay. Firstly, we have created an array and initialized it with the invalid value. So after that, before return statement, I have just stored the value in an array. Same I did it here also. So after that, we have just checked it, like if the value is not invalid, if we are having some valid value, we will directly return the value whatever is stored at this particular index. So you can see when it will come at this point, Fibo of 3, it will not go beyond this part. It will just return from after this statement. So see how much computation it have saved. As you can see now, our time complexity changed to 2n minus 1, which is big of n. So you can see like how dynamic program have optimized the solution from 2 to the power n to big of n. So let's catch up in the next video. Bye.